Good morning. Okay. Wow. My cousin made me this mask and sent my family some. It's so cute. It's got little daisies on it. Um, but my goodness, these things are hard to breathe in. Oh, and I'm afraid this is going to be like our new norm. Okay. Anyway, we are at about week 6, and one of those weeks was spring break, obviously. So we're getting to about week 4-ish of my mini lessons, 4 or 5. I would really like you to stay on track, stay caught up with all of your work so that I don't have to call home with anything, that you are missing. So stay on top of your work. It's always on Google Classroom. And remember, I'll be sending all of those emails home, okay? Office hours, Mondays and Thursdays. CP classes, 12 to 1. Honors classes, 1 to 2. Okay, let's get started. We are continuing with probability, okay? So probability is, the chance of something occurring. And I apologize, Lucy is in her crate crying right now. So if I say, Lucy, no, she's being a little bad. So this week we are going to be looking at compound probability, and that is basically what is the probability of multiple events occurring. So I say, what is the probability that I first pull out an ace from a deck of cards, and then the next card I pull out is a king. So there are definitely different types of probability, and this is the most difficult that we're going to get into. So let's take a look at some examples, which always help us. The first one, what is the probability of rolling a 2 and rolling an even? Now, I italicized and for a reason. It is very important in our probability terminology. So let's first start with what's the probability of rolling a 2? Well, we know that there's only 1, 2 out of 6 numbers. On the other set, and the probability of rolling an even, well, there's 2, 4, 6. That's 3 evens out of 6 total. Now, don't forget, anytime you write probability as a fraction, you have got to bring it down to simplest terms. Reduce, reduce, reduce. So let's take a look at 3 6. 3 goes into both of those, so this reduces to 1/2. Okay, here's the fun part. You want both of these probabilities to occur, so we have to put them together. And in the past has always told us to add, because, like, for example, if I buy 3 cartons of milk and 2 pounds of meat, I would add those totals together. But with probability, it's different. And is actually telling us to multiply. So we're going to do 1/6 times 1/2. Now, if you forget how to multiply fractions, you just go straight across. So 1 times 1 is 1. 6 times 2 is 12. Here is your final answer. The probability of rolling a 2 and rolling an even would be 1/12. Okay. Move on to the next example. What is the probability of spinning a 2 and then spinning a blue? Okay, well, let's start with spinning a 2 first. There's only 1 2 out of 4 numbers. Now let's talk about spinning a blue. There's how many blues? We see 2. Well, there's 2 blues out of 4 total sections. So we're going to multiply these. I like to reduce first. If you reduce first, you're going to have smaller numbers to multiply. It makes it much, much, much easier. So let's reduce 2/4 again to 1/2, because 2 divided by 2 is 1. 4 divided by 2 is 2. So we're going to do 1/4 times 1/2. That is 1/8. Now it's really hard to spin a 2 and then spin a blue, because there's multiple options. It's when you get into compound probability, it's going to be really difficult to do 2 things in a row exactly as you want them. We should know that, okay? Kind of a little bit of common sense, but we're just doing the mathematical reasoning of it. And next, what is the probability of drawing a red crayon? Okay, well, a red crayon, there are 4 out of 1, 2, 3, 4, 5, 6, 7, 8, 9, 10 total crayons. I know those don't actually look like crayons. That was the best I could do. And then without replacing the red crayon, drawing a purple crayon. Well, how many purples are there? There are 3. Now this is tricky. We didn't put the red back, so let's just pretend we took 1 out. Okay? How many are we left with? Well, there were 10, so now there's -1. There are 9. So there were 4 possible reds here. Okay? I want to explain this. There were 4 reds. We could draw one of the 4. If we drew one and do not put it back, you're only now left with 9 crayons in the bag. Okay, so really think about that. If you need to pause the video or rewind to watch that one more time, please do. I'm going to move on because I have to multiply these, but I want to reduce first. Let's make 4/10 smaller. Let's divide them by 2. That would be 2/5. Let's make 3/9 smaller because you can divide both by 3. That would be 1/3. So now all we're doing is multiplying this. 2 times 1 is 2. 5 times 3 is 15. So the probability of drawing a red crayon and without replacement drawing a purple crayon would be 2/15. My last example of compound probability is with a coin. What is the probability of flipping heads on a coin 3 times in a row? Okay. Well, what's the probability of flipping a heads in general? Just once. It would be 1 out of 2 sides. Okay, again, we flip it. It's still 1 out of 2 sides. And for a third time, we flip it. Again, it's 1 out of 2 sides. Well, we want all 3 of those in a row. So again, we're going to multiply. 1 times 1 times 1 is, 1. And then 2 times 2 is 4. 4 times 2 is 8. Your probability for this one is 1/8. Okay. That is compound probability, and I would recommend you maybe watch this video a couple times in a row to help you. I'm now going to explain 2 probability vocabulary terms. So basically, with probability, there is a probability that should happen, and then there's a probability that will happen. Okay, this is vocabulary, so it's, most vocabulary is just memory. So what I'm going to ask you to do is really practice this. Think of situations that could be these 2 different types of probability. Let's take a look. We have theoretical or experimental probability. So I want you to think like Mr. Rebellis, for those of you who have him for science, or Mr. Whitehead, or Miss Bird, or Miss Davenport. Think about how you do experiments. Science requires you to do experiments. That's what you're actually doing. I want you to think about that with probability, okay? So theoretical is what should happen, okay? Experimental is what does happen. Now, they're very different, and I'm going to give you the easiest example. If I flip a coin 10 times, I should land on heads 5 times, and I should land on tails 5 times, because the theoretical probability is 1/2. You should get heads half the time and tails half the time. So what I'm going to ask you to do is pause the video and get a coin. I want you to flip it 10 times and see, did you get heads 5 times? Did you get tails 5 times? I'm going to do the same. Okay, so I flipped my coin. And actually mine came very close. I ended up flipping heads 6 times and tails 4 times to get a total of 10. So I just want you to understand the difference between theoretical, it's a theory. It should happen this way. That's what we have been finding in the past. That is the probability we've been finding. Until you actually do it, that is the experimental probability. Okay, so you're going to have 2 assignments attached to this video. The first is analyzing, is it theoretical? Is it experimental? You're just going to choose between the 2. And the second assignment is you are solving for compound probability. Please take your time. Remember, I am taking mini lesson points for a grade, okay? All right, miss you guys so much. Make sure you stay safe out there. Peace.